Yes, welcome to another presentation on this concept of the random variables. Concept of random variables. Since last presentations, we have been continuously discussing about the important parameters of a given random variable x, out of which we have seen the first one is the very important one, that is the expected value of random variable x, right? And the second one is the variance of a random variable x, right? So in today's presentation I would like to solve one very important question, okay, based on this variance concept, right? So this is the given problem. If the given random variable is ax, right? If the given random variable is ax, find the variance of ax, right? Find the variance of ax. So how this can be solved? Very simple. Very simple. How? So here the given random variable is a into x, right? Normally what we know? Normally we know that for any random variable x, okay, so for the given random variable x, the mean value is nothing but expected of x. This is furtherly denoted as mu. This we know, is it not? For any given random variable x, the mean value or the average value or the expected value of x is denoted by E of x, and that is equal to mu. And similarly, for this x, what is the variance? For this x, what is the variance? Variance is nothing but sigma square of x. Okay, variance is denoted by sigma square suffix x, and it is mathematically, this can be given as expected of, right, the random variable and its mean value, means expected of x, and then whole square. This is what the definition. This we have seen in our last presentation. So variance of x is equal to, it is expected value of the square of the difference between the random variable and its mean value. So now for solving this particular question, we have to consider the variance, this particular definition, because we are going to find out, you are asking in this problem to find the variance. Variance is nothing but this is the formula we have to use, right? So how the variance of ax? So these are the formulas with respect to random variable x. Now, in the given problem, the random variable a into x, a is a constant, right? Here a is any positive constant, okay? A is constant. Therefore, here the given random variable is, what is that? Given random variable is, what is that? A into x, right? A is some constant, x is, however, it is a random variable. Random variable is multiplied by some constant a. So the overall a into x shall be considered as a random variable. Now for this, what is the variance? Variance is nothing but sigma square of ax. Is it not? Because if it is random variable x, we have to write sigma square x. But here the random variable is a into x. Therefore, you need to write sigma square suffix a into x. This is equal to, tell me what is the problem? I mean formula, expected of the difference between the random variable. What is the random variable? What is the given random variable? A into x. A into x is the random variable minus the mean value. What is the mean value of ax? Mean value is nothing but expected of a into x, right? So this is the random variable minus the mean value of ax is nothing but this, and take the square for this difference. Take the square. That's it. That's it. So this is the formula, right? So your problem is solved now. Your problem is over. Clear? So this is the formula that you should remember. But upon a very simple simplification, this expression furtherly can be simplified as follows. I will little bit expand this in the next step. Understood? So sigma square ax is equal to expected of ax minus expected of ax square. Now, if you expand that, what you will get, So, if you expand this particular expression, what you will get, So, sigma square ax is equal to, let expectation will be there, right? So, this is a into x. Let us take a as common there. So, a into x, no? Here also expected of ax. So, remember that expected of a into x is equal to, a is a constant, take outside, a into expected of x. This is the one of the important property of the expectation. Okay, if any random variable multiplied by some constant, then for that, like this, in this fashion, if anything is given in this fashion, a into x, so take this constant outside, means like this, a, then take the expectation for this random variable, means that a into expected of x only. Therefore, if we apply this property here, you can take this a outside. Okay, if you take the a outside, then what you can write, expected of e of x. Therefore, right, so otherwise I will write a into x minus here a into expected of s. Shall I write like this? For this whole square you have to write. Any confusion is there in this? Nothing. I have not done anything here. Just okay. So you have to take a as outside because it is a constant. Therefore, if you put this a before this e, a into expected of x, is it not, in this fashion? So the whole square, however, it will be there. Okay, understood? Now it is very clear, no? This is equal to expected of, now, so this is the first a term, minus b. So in these two terms, a is there, no, as a common, a is there, take a as common. Therefore, what is there actually, x minus, if you take this a as common outside, what is there, e of x whole square. This is equal to, okay, this is equal to, in fact this is total. Actually, this square is there for total, not only that, for this entire, the square term will be there, for this entire, the square will be there. Therefore, it is a square, this is nothing but e into a square into x minus e of x whole square, is it not? Therefore, you can take this a square outside, this is a square into expected of, what is this, x minus e of x whole square. This further is equal to a square into sigma square of x. That is the formula. Understood? So, in fact, the square is, so this square is there for the entire. Therefore, if you take a as common, in this first term as well as in the second term, a will be there. If you take outside, so a square, you can take a square as common. So, if you take a square as common, then what will be there? X minus e of x whole square. X minus e of x whole square is nothing but the variance of x. The variance of x, because we already in previous presentation we have seen that the variance of x is equal to, what is this actually? Expectation of random variable x minus its mean value square. Therefore, see this? So, x minus e of x whole square means that this is nothing but the variance of x. Therefore, what is that? A square into variance of x. So, in simply, we can say that the variance of any random variable x which is multiplied by a, that gives a square terms the variance of x. Okay. In simple, I can finally conclude this as, understood? It is very, very simple. It is very simple. In fact, this is one of the very, very important property of a variance, means that it is the variance of the random variable x which is multiplied by the constant is equal to a square times sigma square of x. That is the property. So, in GATE examinations for one more questions can be expected this question like this. So, sigma square a into x is equal to a square terms the constant, means that some 3 into x, let us say for example sigma square into some 4x is given, 4x is given, then what is the variance? So, it is as per this formula 4 square you can write, 4 square into sigma square of x. What is 4 square? 16. Therefore, 16 square of x. That's it. This is the answer. That's it. Therefore, you need to remember the formula. Understood? I hope you understood this, and this is one of the important property of the variance, right? So, I hope you understood this well, and with this I will finish off this presentation here, and we'll continue with many more examples in the subsequent videos. Not only that, in the subsequent presentation I would like to give you the very important tips and the topics which are exclusively more important with respect to the GATE examination point of view, right? There are few topics actually, we should focus on those, and let us see the concept and the problems also, right? So, with this we will finish off today's presentation, and thank you for watching this video.